All right, this is the Container Storage Interface Community Meeting. Today is February 3, 2021, and let's go ahead and get started. So a few items on the agenda. I noticed that the Zoom link was out of sync. We changed it a while ago, but I think there were some entries that were out of sync. So I just want to call out that the Zoom link, the proper Zoom link, is at the top of this doc. And I also updated the invites to make sure that that's clear. Moving on, next item is from Patrick, clarify semantics for get capacity response. Patrick, would you like to share your screen?
I can try. Just a second. I do have the issue open somewhere. Share screen.
I think we have to. Do you have permission to share screen?
I know. I don't. Host disabled participant screen sharing is the error message that I'm getting.
Michelle, can you give Patrick co-host permission?
Yeah. If I don't get sharing enabled, just go to that one issue. Okay. Seems like it might work now. Okay, so what I'm sharing is basically the open issue. That's really what it's all about. This issue has been open since I started working on storage capacity tracking in Kubernetes. My observation was that for the existing spec, we have one value in get capacity response, which is just saying capacity, and it wasn't quite clear what that value actually tracks. So suppose I have a volume, I want to create a volume of a certain size. If it's smaller than this value, can I actually be sure that I can create the volume? And that's not that clear, because if the CSI driver implements fragmented storage or storage that can potentially get fragmented, then I might have two chunks of capacity. If I add them up, I get a total capacity that is larger than any volume that I can create. That leads to ambiguity. My proposal, therefore, was to distinguish between total available capacity. That's basically all capacity added up, and the only way how to actually get that much storage might be that you need to create a suitable number of smaller volumes. And then for the use case of determining in advance whether a create volume call has a chance of succeeding, we need something that I call the maximum volume size. And the driver, because it knows how it creates volumes, it knows its current fragmentation state, it can check whether, or it can deduce what the maximum volume size would be that it can create. So I think this is implementable. I think it would be useful for the Kubernetes feature. The question is how exactly we, if we agree that this needs to be extended in the spec, how we do it.
Does your proposal go to the next level of suggesting new fields?
It does. So the proposal, let me see whether I can highlight. No, I made it larger. Not sure whether you can see that. So the proposal here in the issue was that we keep the existing capacity field. We obviously still need it for backwards compatibility, but we clarify the semantic. We say that it is ideally the maximum volume size, because then drivers or users of that field who want to compare it against create volume sizes can do that, and it actually makes sense.
But I would dispute that that's the backwards compatible definition, because I imagine that if there is a driver that has this problem, they probably are currently interpreting capacity to being the total available number, and they're returning that, even though it's not the maximum volume size you can create. But the spec suggests that what you should do is sum up all of your free spaces.
I don't think it does. It doesn't actually say anything about that. But yeah, okay. I'm fine with also that, as long as we agree on some other fields, and here I'm not sure what's the better approach, with whether we should add two fields, which both then are completely unambiguous if present, or if we just add one additional field and say that it has the other semantic, whatever we define as the default semantic.
I like the idea of redefining capacity to be total and then to add the maximum volume size. I think that fewer drivers will have to change as a result of that. And then what you're interested in is the maximum volume size. You basically have to look at the new number, the new field.
That works for me. That means I need to change my proposal and then submit a PR with that other proposal.
I remember having a lot of discussions when this was first being introduced, and at that time we decided not to do total available capacity, and I can't remember the reasons why. Does anyone on this call remember why?
Well, one problem is very frequently it's effectively infinity, and you can't give a number, right? Or it's some number that's constantly changing, or you're growing quickly, and in a cloud environment like GCE, for example, that there's no capacity. It's just Google will sell you as much as you can afford. So if it's infinity, you need to basically have a way to communicate that like, hey, there is no, you're never going to run out. The only thing that matters is the maximum volume size you can
get. In that case,
so I think 0. Do we have a number for like not supported? Can a driver return not supported for a call?
You can, but in this case, you don't want to do that. You want to say just this one field is not supported, but here's the answer for their max volume size.
The answer then would be, well, the backwards compatibility change would be max int 64. That's the maximum total capacity if it's basically unlimited. It's not a nice number to print, but it could be set in that field. So I'm looking at the spec, and it currently just says available capacity is required, must not be negative. It doesn't say anything about whether it may be 0, but probably it would be expected that if you have the ability to create something, that it's non-zero. So I would argue, if we clarify available capacity to be total available capacity, then we can basically allow max int 64 as the compatible value for.
We could also put it behind a new capability flag, and if you don't support the idea of a total capacity, you just don't advertise the flag. If you do, you advertise it.
But
I'm trying to check.
Capability is heavier weight than just some sentinel value that is defined in the API.
I agree. Just looking at the get capacity response that has two fields should be already a unique identifier or unique enough to distinguish what the driver actually supports. We don't need contextual information from the capabilities for that.
Yeah, I like just putting verbiage in there. Return max int 64 to mean, effectively really unlimited. And so that clients who are consuming this will know that if they ever get max int 64, not to interpret it literally, but to interpret it as just really, really big.
I'm trying to check what PD driver is doing, because I'm pretty sure we did not implement this, and because, as Ben said, like, we basically have infinite capacity. It looks like we just return unimplemented error.
Yeah, and that's fine. That just means that there is no capacity information at all for your driver. And if you want to change that and implement something like a maximum volume size, you would have to change your implementation to return a get capacity response and set the available capacity to that large number.
So I think, Saad, going back to your question, you were asking about the total capacity that we were debating on a while back. That is a different issue. that was debating on total capacity, not just total available capacity. So it's total including available and used. And the
Got it.
reason for this is because that a total capacity that includes both aligns more with how the Kubernetes scheduler does resource accounting today. The main downside of this total available capacity is that the number immediately changes after you provision. So the scheduler cannot really schedule things in parallel effectively because the subsequent pods are going to be scheduling with outdated capacity information, and they may go and try to provision pods on nodes that don't have enough capacity, and then you could, get your pods can get into a state where you have a few volumes that were successfully provisioned and then a few that were not successfully provisioned because there's no more capacity left.
What's the scenario where you have this information at the per node granularity? Because I thought that this was cluster wide.
This is for like a local volume as an example.
And it's for a certain topology. No, it's for a certain topology. So the get capacity parameter, the get capacity request actually gives you topology, volume parameters, volume capability.
Right.
So it is
I'd forgotten about that.
Yeah. So the response can be for one node if that's what the driver supports as topologies.
Right. So then, go ahead.
Well, I was just trying to replay what Michelle said. The challenge is that if it's an always changing number, it prevents your ability to do things in parallel. And I'm wondering, like, is there a way around that to make the scheduler smarter so that it can sort of keep its own tally and then deduct and add as it goes?
That was exactly the issue that was proposed in the spec change in the spec issue 301. That relies on getting the total capacity, which presumably is fixed, and then letting the scheduler make some assumptions about how that total capacity is spent to provision volumes. The objection in that older issue is indeed that this modeling makes lots of assumptions about, has to make assumptions about how storage is handled by the CSI driver.
Yeah, I was going to say, I can immediately see issues where that would fail.
Yeah,
because
but that was the objection against adding total capacity, because it's only useful if you do that modeling, and that modeling itself was said to be flawed and not useful. Therefore, total capacity was basically vetoed at that time. What we've settled on for Kubernetes is to accept that we get outdated information, whether it is total available capacity that is no longer quite up to date or maximum volume size that it's not up to date. We just use that to guide the pod scheduling towards a node that at least at some point had the capacity. And then we try to create volumes. We recover if that doesn't work, or we recover at least in the simple case with one volume per pod. So it works better if we have that information and if it's accurate. That's why this issue here is about making the available information more accurate and more precise, so that we don't get confused in Kubernetes when we compare a volume size against the available capacity, and it means one thing in Kubernetes and something else in the CSI driver.
Can you elaborate on that a little bit more? What use case does this make better?
So suppose I do have a volume. I want to create a volume of 100 gigabytes. I do have one node which has two disks, separate disks, and it reports a total capacity of 100 gigabyte for that node because it has two disks of 5 gigabytes each. If I then conclude that this node has enough storage for my volume, I may end up scheduling that pod and therefore the volume towards that node, and then create volume will fail because it can't create a 100 gigabyte volume without something like LVM, which might not be available. So it basically fails the create volume call, although available capacity said that, yeah, I do have 100 gigabytes. And in this case, the driver who knows that it has 2 disks and can create 2 volumes of 50 gigabytes can return total available capacity or available capacity of 100 gigabyte and maximum volume size 50 gigabytes. And then Kubernetes will know that it needs to look for a different volume, a different node, a different topology segment, basically where the maximum volume size is actually 100 gigabyte.
I guess what I'm kind of confused on is why wouldn't the driver just return 50? Like if we're gonna say Kubernetes can only schedule 1 pod at a time or 1 volume at a time, and we have to, then isn't that equivalent to just setting the available capacity to 50?
That is the other option. We just redefine available capacity to mean that is the maximum volume size and ask drivers to report that.
Yeah, my question is, does knowing the total available capacity give the scheduler any more useful information? Like, could the scheduler say, okay,
no,
this node has 100, I just put a 50 gig volume on it, so I expect there's probably 50 left.
No, I don't think it can make that judgment call because of fragmentation. The total available capacity then is mostly for backwards compatibility, because some systems might assume that this was the meaning of a value, or it might be used to, I don't know, sort nodes perhaps. So if you have
like I would kind of argue if like having the 2 values is not actually going to change the scheduler behavior, then we should actually consider having 2 different values actually mean 2 different things that will influence the scheduler behavior.
I think that's what the proposal is. And I like the example you just gave of sorting. Like maybe you have 2 different nodes that both can handle the volume, but one has a lot more spare capacity. The scheduler could prefer that one if all else being equal. So it is a useful number to have in addition to the maximum volume size.
And it might be useful for just statistics for people who are not looking at a metric that may or may not be implemented by the storage system, but actually look at get capacity response to determine how much free space do I have on this node, and without actually trying to determine what the maximum volume size might be in that case.
Sorry, can you explain the sorting to me?
The idea was that if we have parallel scheduling going on, the risk of running out of storage on a node is higher if we put everything onto a node that doesn't have lots of free space left.
Mm.
If instead we prefer a node that has more storage left, then there might be a chance that we actually get all volumes created on that node. That's the only thing that I can think of, and I can imagine that people may have different policies for scheduling. The current cap doesn't go into that. It was intentionally excluded because we weren't sure what the policies might be, what's useful. But this
if you have per node availability information, you could do some sort of a stochastic weighing, to distribute your pods in such a way that you'll run out of space on every node about the same time, which is an ideal outcome if space is your main constraint.
Yeah, I can imagine that someone will look at that at some point and will try to come up with a suitable policy, and then it may be useful to just have the total available capacity as an additional input for that scheduling policy.
Yeah, and if you don't know it, we just need a value to return that says, I don't know.
Well, if it's not different from the maximum volume size, then just return the same value for both fields.
Yeah.
That's not different from the current situation. But it still gives us the opportunity for those drivers who do have a distinction between the two to return that information. I have one other question about, so I think, let me try to recap. Let me see whether we now have a consensus on a path forward. Let's make available capacity, or as it is, we clarify the meaning as it is total available capacity. We give instructions on how to handle that for the case of infinity, basically saying we return int 64 max. Then we add a second field, maximum volume size. This one, I think, actually needs to be a pointer so that we can distinguish between value is set, value is 0, and value is something else. And as a further clarification, we can basically describe what drivers should do that don't have a separate total volume, a total capacity. They can just return the same value for both, but they should set the maximum volume size to make it unambiguous what that value is that they are reporting. Does that sound useful and like something that we could do?
I think that sounds fine. The only concern I have is how valuable is this? Do we have some immediate use case where we're going to consume this, or are we adding this because it's a hypothetical in the future?
No, I would immediately use that in Kubernetes. The current usage is we have the CSI storage capacity objects. They store the values that we get from the CSI driver almost verbatim for different topologies. And then the kube scheduler looks at volumes and tries to find out which node has capacity. And it currently does that on this, based on this ambiguous available capacity field.
Got it.
If we have maximum volume size reported by a CSI driver, the kube scheduler would use that value instead for the comparison. And that improves scheduling for those drivers that have fragmentation that actually report two different values.
Right. So, and we wouldn't consume the total available immediately, but we don't want to get rid of it because we're aware of how we would use it later.
That's correct, yes.
Would this also help for thin provisioning scenarios where the maximum volume size might be much bigger, but the actual capacity might be potentially lesser?
That is an interesting idea. Nothing would prevent that. We can actually clarify that in the spec and saying that it is okay to report a higher maximum volume size, as long as the meaning really is, yes, you can create a volume with that size, then that makes sense, yes.
But we're really not differentiating between C and SIG here, right? We're just assuming whatever value we got are all real capacity that's been used or available. We're not really checking.
No, I mean,
we're not differentiating here. I mean, the scheduler, I think, right? So if we have this two value, well, one is for thing, otherwise, I mean,
the decision to use thin is like a risk that a storage admin can take if he knows that he has a way to deal with over provisioning when it occurs, right? Like you could have a system where like you have I don't know, a couple hundred terabytes, and but you know it's mostly full, so maybe your available capacity is only 50 terabytes, and someone comes along and says, hey, I want 100 terabyte volume. As long as your system's able to say, sure, I can do that, and in the background, some administrator is going to go add a bunch of disks to the machine to actually increase the available capacity, it's no big deal. But someone has to upfront decide to switch on thin provisioning because they want to take that risk.
Yeah, I just feel it's not safe if we just go ahead and
I guess
recommend them do that. I mean,
I guess in these fields, what are we going to require the driver to return? The thick capacity or some thin one?
The maximum volume size has to be just the maximum volume size that will succeed. And if thin provisioning is turned on, that's always understood to mean that like you may run out of space once you start writing to the volume, right? That's you always succeed in the creation of the volume of whatever size within provisioning, and where you run into trouble is when you try to write the data. but that's a operational problem that always exists within provisioning. You can't avoid it.
Right, but we don't really have anything else to check to see like how much might be consumed. We don't have anything like the subscription, like the maximum subscription ratio, things like that. We don't really have that in the scheduler to check that. So
No,
if
but I
we
mean,
kind of recommend them.
the scheduler is not part of CSI. Like someone could go write a scheduler that took all that information
Right,
into
but
account.
I think we're talking about like the scheduler. Patrick's going to change that scheduler, right? That's what we are discussing right now, right? So we're not really talking about
the two pieces of information, which is maximum allowable volume
I'm just
size
saying, like,
and
if
total available.
I think if we just write that in the spec saying, oh, you can just do that, I'm afraid it causes some problems. They say, oh, you say you can do it, why this failed? And then it becomes our problem. So I don't see that we have a clear way that can prevent people from making that mistake. So I'd rather not even mention that.
I don't know. I think the problem would be on the vendor. If the vendor doesn't understand what they're doing, like they have bigger problems than their CSI driver behaving weird.
I think it's really not easy to describe clearly like how it should behave here.
I think you say the maximum volume size is just the largest volume that will succeed creation, to say nothing of what will happen when you try to write to that volume.
But then you're saying the total. I mean, I think what I found very confusing is if we say the maximum size is for what the things, whatever you want to create, and then the total available capacity will be what the real one that is consumed.
It's how much free space is available right now, and that's always kind of an estimate, right?
So actually,
I guess it's a little weird, right? If we're saying maximum volume size is like 100, but then your total available is 50, like it does seem kind of.
Explain that clearly. We don't really have a clear way to say.
So this could be an opt-in behavior, right? It's not something that would happen by default. If you have a storage class that sets thin provisioning on, and thin provisioning is a parameter that your storage vendor exposes, then one of the possible behaviors that can happen is what's described here, where the total volume size can be larger than available capacity. And if Kubernetes sees this happen, it knows, oh, okay, there's some thin provisioning going on. Whether Kubernetes does anything special about it, TBD, but it effectively allows thin provisioning to be handled.
I just feel if we allow that, we'll get a lot of questions and we go to we're going to be explained.
I do think we need to specifically kind of clarify that in the spec because it will come up.
We should have some verbiage that explains what COs are expected to do with that information so that vendors have an idea of what number they should provide.
I wonder if we should even add something like you turn on thing or SIG or something like that to make it more clear. Otherwise, it's all just what driver, whatever they want to report. I mean, it's not really clear what they're reporting. It's very vague. If we don't have if we don't say if this is thing or SIG, right? If we just say, okay, whatever you think you can handle it, you can just report that. I mean, I think it's very difficult to explain why that would make sense. I think it's better that we actually have a property they are saying, okay, this is the same provisioning that go with this size, then that will be much more clear.
I don't think there's any generalized way to expose that. I think if you're not happy with just giving a number, which is the storage system's best estimate of how much free space there is, then we would just not return anything at all.
I mean, we can table this for now since it's not the primary goal of this whole discussion. We can table it and keep it tight and say nothing about thin provisioning, and in the future expand to cover thin provisioning if we want to. And when we do, we can decide whether we should have a new explicit field that also goes along with this, or just the capacity values.
But not specifying it, that leaves ambiguity, because then people don't know whether it's okay to specify a maximum volume size that is larger than
But it's ambiguous today, and what we're proposing is a step forward, right?
Okay, that works for me.
Yeah, I feel like if we allow that, then I feel like our schedule needs to be changed to handle things differently. Because then you're calculating what is available, then it's, it's different. Right?
I mean, actually, what would change in the scheduler?
Nothing, I think. That's why I don't see a problem with allowing that and documenting the semantic, because we are not expecting anything to happen in response to that. It's just really answering a question that someone may have who looks at this.
Right.
But you are okay? So you're saying you're not really using the available capacity right now.
Not in Kubernetes today, but like a hypothetical future scheduler could.
Right. So when I think the problem probably will come when we start to use that, right? If we are not using this, we right now only use the maximum volume size, then just whatever it is the driver says they can support it, they should support it. Otherwise, that's a problem. But if a scheduler is also calculating the total available capacity, I think that's the time then it needs to know whether it's single sig, and I think the calculation
that's
could be
true.
different.
Yeah. Yeah, if schedule is calculating total available capacity, then we have a problem. And I think this was raised previously when we had the discussion about the scheduler trying to model available capacity, and one of the concerns was thin provisioning, and other concerns were, replication and all of these things. So it's difficult to model, and so we punted on that problem.
Okay, so basically then the definition of available capacity remains vague as it is now, and we just introduce a more clearly defined maximum volume size.
Yeah.
Is that the conclusion?
That's what I would like. Yeah, and then if we want to sharpen up the other value or add more fields later, we do it.
Yeah,
okay.
I think that's fine.
And just to clarify, in the context of Kubernetes, the scheduler will look at the available capacity or the maximum.
Look at the maximum.
When it looks at a single volume, it will look at the maximum volume size if available.
If available.
And that comparison then is clearly defined based on the semantic of that field, and it should work as intended. So. Okay. It sounds like I have all the information to put together a PR against the spec. And if I don't get it right, we can still discuss in the PR.
Sounds good. And just to make sure I understand this clearly, the benefit here is that the field that exists today is ambiguous and can be misused. And so we're adding in a new field that is less ambiguous and will be used immediately by the Kubernetes scheduler.
Correct.
And the existing field will be kind of tightened in its definition and could be used in the future if we start doing modeling of storage in the scheduler.
Yeah, but we're not going to tighten up the definition of the existing field. We're going to leave it. Like in the future, we might tighten it up, but for now, no.
We might add a recommendation to if it makes sense for the driver, we allow them to return a different value for available capacity if it makes sense for them, but we don't really require a certain semantic.
Which is exactly what we have today.
Yeah.
I see. So effectively, we're just abandoning this field and adding something that's more useful. Okay, I think that's fine. And in terms of backwards compatibility, since the new one is going to be a pointer and optional, that means a existing driver will not fail because it'll just leave it empty. And the CO would need to handle the use case of the new field doesn't exist. What do I do?
Yeah, right. In terms of rolling that out in new CSI spec release, do we know of a timeline for that? Is something planned already?
So when we spoke at the beginning of January, the plan was to align a new CSI release with Kubernetes 121. And so conclusion was that we should target a CSI 1.4 release by the first week of February, which is this past week, or this week. If the assumption was that code freeze was going to be sometime in February for 121. Now, if I understand correctly, code freeze is actually a little bit further out for 121. Specifically, it is on March 9. And so, yeah, if we really want to get something out, we should cut a CSI release in the next 1 or 2 weeks.
Yeah. Well, I think this, now that we've thoroughly discussed what we want to add to the spec, I think the actual PR should be fairly easy and hopefully can get into that 1.4. And that will be useful because I'm planning changes in Kubernetes for 121, where I can immediately start using that new field. That's perfect.
One more thing is all new fields should go through alpha, beta, GA, so we avoid the kind of headache we had with renaming. Would you be okay marking this as alpha and then subsequently updating it
Of
in
course,
future releases?
If,
okay.
If that helps, yeah.
Cool.
So would that be a problem with this is alpha in CSI and then this feature in Kubernetes going to beta?
I think we can still use it if it's available and just fall gracefully back to not using it if it's not.
Yeah, the fact that this is being added to the spec means that forever, whoever the consumer is needs to handle the behavior of it not being available.
Yeah.
And so it can be opportunistic. If it is available, use it. If not, fall back to the old behavior.
Okay. And Patrick, in the existing alpha code, you're using the available capacity today, right? Whatever is there.
Yes.
Okay.
Yes.
You'll be replacing that one with this new.
I would extend the CSI storage capacity object to have 2 values, just as in the spec itself.
Okay. But then you will be like the scheduler will be using this field, not that one.
Yes, and then the scheduler will do the same if available, check and use the maximum volume size if it's set, and yeah.
Okay.
Okay.
All right. Thank you, Patrick.
Thanks.
Any other topics of discussion today?
If there's nothing on the agenda, I was just going to mention that Yassine and Xing and I are making some progress on the force detach design, and we have a very, based on the proposal I made back in September for CSI changes, it looks like something very much like my September proposal is what we're going to go with at the CSI level for that force detach feature. So I will be proposing a proper spec change with PR in the next month. So by the next meeting, you should see
Sounds
that.
good.
We don't need to go into any detail here unless people are curious.
Makes sense. Okay. Thank you for the heads up. Anything else? All right. And then we can end a little bit early today. And I guess next question is, do we want to have a meeting in 2 weeks? Because I believe the next one is in 4 weeks.
What would we talk about in that meeting?
I guess if we're on track for cutting a release or not. I guess that can also happen offline. So if folks are okay just doing it offline, then we can skip the next meeting. Or we can skip the 2 weeks and just do the regular 4 weeks. Okay, in that case,
I'm okay either way, yeah.
Leave it as is. And if someone has anything they need, feel free to shoot out an email to the group, and we can take it from there. All right, take care, everyone. Bye.
Thank you. Bye.